Well, we need it done in 3. If I had been here Friday, it would have helped. Here's what I'm shooting for. Now, y'all know me. I'm not gonna rush it. If it starts to feel like it's spiraling out of control, getting rushed, then we'll have to just reassess.
Wait, so you want us testing
This Friday?
Is that what you're trying
No.
No. So today's the 5th, right here, and y'all do not come to school on Friday the 16th.
That's my birthday.
Is it?
Yeah.
Well, you have the day off. You're welcome. I want you to know I asked and I got it approved. So the goal is I'm trying to get the test on Thursday the 15th, so that long weekend when you have Friday and Monday and Tuesday off, you're not studying for the test, the end of chapter 6 test. So that's the goal. Okay? So if it feels a little bit like there's no breathing room, it's because there's not, and that's the goal. It's so that you have a long weekend of breathing room, okay? If as we get closer, I'll check back in. I'll be like, okay, are we going to make this? We're going to be able to do it. And if it's a group, majority vote, no, this is too much. This is too much. Then we'll slow down. But that would put the end of chapter 6 exam after that long weekend. So now you know what I'm shooting for, okay? So 6-4. Originally, I spaced it out really long into 4 days. It is doable in 3, but you're going to have to lock in and make sure you're staying on top of the practice problems, okay? Yes. 6-4 is the longest one, though. 6-4 is laying the foundation of the unit circle, which is really important, okay? So make sure you're paying attention to this. Go to this slide right here. If you have a highlighter, it might help. If you don't have a highlighter, you could just box it in. But basically, what is the unit circle? The unit circle is, I got the hiccups, hold on. Trying to get rid of it. It's a circle whose radius is 1 unit, hence the name unit circle. Like the radius all around is 1, measures 1. Every day, all day. And it's always positioned on the origin. The center is on the origin. So it's nice and symmetrical, okay?
I thought I've seen this before.
You have. This picture should look familiar, right? Similar. Like we had a triangle over here. So if you notice this red line right here with the 1, that's the radius, just showing you that if it swung all the way around, it would be 1. Which, as you've already practiced, makes sense why this point is 0, 1. This point is -1, 0. This 0, -1, and this 1, 0. Like that now makes sense because of that unit circle, right? So that's not anything new. If you have a point that is not landing on one of the axes, we've been calling it point P. It has an X and a Y. We have already practiced that the X is laying on the x-axis, the adjacent, right? And the y is the height of it. And then to draw the triangle, it comes back to the origin, right? Now the new part here is what you're used to being x, y, and r. We no longer need r because now we know r is 1, which is why this is down here. X squared plus y squared equals 1 squared, which is 1, so that's why the squared's not there. So this is the new part, is that we no longer have to worry about r because we know we're in the unit circle. R is 1 in the unit circle, okay? If you recall, Do you remember what circumference means in terms of a circle?
1/2 pi r squared.
Well, what does it mean? It was all the way around. It was the fancy word for perimeter, right? The circumference of a circle was the perimeter of the circle. Do you happen to remember the formula for circumference? If not, no big deal.
1/2 pi r squared.
Not quite, but I'm so glad you tried. Nope, that's area of a circle.
Pi over 2 r squared.
Nope. I'm gonna rescue you.
That's dumb.
2 pi r.
Do you know the song? I don't remember the song.
No. I know the song for quadratic formula.
X is equal to negative b plus minus square root of b squared minus 4 is
No, I'm
equal
trying to think
to
about
a.
this song. That's the only song I came back to.
The circumference of a circle is 2 pi r. Now, here's where I'm going with this. This is the formula for the distance around every circle. Doesn't matter the size of the circle because you plug r in and then that accounts for the size. And so you type it in your calculator, 2 pi r, and you get the distance around the circle, okay? Well, what do we know r is? 1. So we can tweak this. So let's make a note. Because we're talking about the unit circle, r is actually 1. So our circumference, I'm going to draw a big arrow to say like, okay, putting that together, our circumference is what? 2 pi, I'm going to replace r with 1, and I get what? 2 pi. I just get 2 pi, right? That is the circumference of unit circle. So why is this important? Because the distance around the entire unit circle is 2 pi. Every day, all day. And the reason it's the same every day, all day is because it's the unit circle which never changes in size. You with me? The unit circle is that every day, all day. So the distance around is 2 pi. That is also the rotation all the way around. Okay, we're getting into what's called radians. Radians is the college level way of measuring angles. You've been using degrees for umpteen years, 3 years, geometry, all right, maybe 2. Geometry and then so far. Now we're getting into radians. I need you to, in your mind, picture these full rotations or a half rotation or a quarter rotation. And where you used to probably not like fractions, I hope that now you're going to like them. And I hope that I can show you that fractions in the unit circle is just a measure of, it's a means of counting. You're just counting the parts out of the wholes, okay? All right, so come right here to these pictures. These are 4 examples of rotations in radian measure or in terms of circumference. So this right here, if you can tell by my colored little arc, you see the unit circle is the black one, but then you have the red that is showing a full, what we used to call what? How many degrees? 360 degrees. Well, because it's going, let me face this way, so because it's going all the way around, in terms of circumference, it's 2 pi, right? So we're going to make a note above it that this is 1. When we say rotation, we mean like one full rotation. It's going all the way. I'm trying to trace it as best as I can. And it lands right here. I don't like labeling the 2 pi down there because it kind of implies that if it was to stop down there, I like to label it up here where it stops. Now, you're used to this being called 360. Today, I need you to start calling it 2 pi. So a full rotation is 2 pi. Always, this is what we're going to do all the time. You're going to hear me say, well, what's a full rotation?
2 pi.
Then I'm going to say, so then what's half a rotation?
Pi.
And that was just a matter of counting. If a full's 2, then a half's 1, right? Okay, so right here, we got, it's rotating, it's landing there. We're used to calling that 180, but now we're going to call this pi. So we're going to say half rotation. And we do mean half of the full, or half a circle. You can say half a circle. It's up to you. All right, now these next ones are the most common fractions we're going to see, along with one more that's not up here, and that's because it comes about when you reduce the fraction, so I'll show you that. But if you look at this next picture, you should notice they are asking you to focus on just this rotation. And when you first look at it, ignore the fraction. When you first look at it, you don't really know like how much it rotated. But if you look at the increments they've marked off, then count them. There's 1 here, 2 here, like, let me do this. There's 1, 2, 3, 4, right? You with me? 5, 6, 7, 8 equal parts there. You see that? Okay. If I have 8 equal parts out of how many? Out of the 2 pi, right? If you think about it, this would be, if you notice right here, this says 1 pi over 4. So this is 1 rotation. Don't write this. I'm going to erase it and rewrite it as something else. Out of the 4 that would bring you to right here at pi, which is 4 over 4. So watch. 1 out of 4, 2 out of 4. What's 2 out of 4 reduced to? 1 half. This is actually pi over 2. 3 out of 4. 4 out of 4. What is 4 over 4 reduced to? 1 pi. 5 over 4. 6 over 4. What is 6 over 4 reduced to? 3 over 2. This is 3 pi over 2. 7 over 4. 8 over 4. Oops, that's a pi.
2 pi.
8 over 4. What is 8 divided by 4 equal? 2 pi. So basically, I took the unit circle. I know a full rotation is 2 pi. I know half's 1 pi. And they have cut, if you focus on just that top half, because that's 0 to 1, they've cut it into 4 equal parts. So you're going to count the parts in terms of 4. And you'll notice that when I got here, I started going higher. So 5 pi over 4. That's because there was 1, 2, 3, 4, and then the 5th one. So I've gone over, right? Because this was pi, and this is past it. Okay? If you're getting it, great. If you're kind of like, I'm not really sure what she's trying to say, then give me time. We're going to have practice problems where it's going to start to come together, okay? Now, what do I actually want you to put on your paper? Hold on. Because I don't want you to put that in this. That'll be too much. What I actually want you to put on your paper is to emphasize, how did I do this? Let's draw this dark. Then let's draw this little arrow here. And we're going to call this was pi over 4. And then to help you see the 4 sections, I'm going to draw disconnected arcs underneath, like right here. 1, 2, 3, 4. So you can see the 4 sections. right, look at the next one. So from the initial side to where we used to call it 180, this is what? That was crooked. Not like that. From the initial side to right here is what? Pi, right? Okay. Now look at the tick marks. They want you to focus your attention to here. They're saying that it would land here. How many sections are there in just that quadrants 1 and 2? You got 1, 2, 3, 4, 5, 6. There's 6 sections. So if you want to draw, if you want to be consistent, try to draw 1, 2, 3, 4, 5, 6. So you can see the 6 sections. All right, this first tick mark that actually does not have the point on it. So we're going to count with 6 in the denominator. You with me? So this is 1 pi over 6, or pi over 6. You're going to hear that a lot. This would be 2 pi over 6, which reduces to pi over 3, which you notice is what they have written here. This would be 3 pi over 6, which reduces to pi over 2. And I already told you, 90 is pi over 2. Another way to think of 90 as pi over 2, if 180 is a pi, then 90 would be half a pi, so pi over 2. Those are kind of like your anchors, okay? So keep those in mind. This would be, let's see, 1, 2, 3. So this would be 4 pi over 6, which reduces to 2 pi over 3. You with me? This one right here. This would be 5 pi over 6. Checkpoint 6 pi over 6. Do you get just 1 pi? Yes, you do. Then you counted it right. You're going to use those quadrantal angle measures as checkpoints to know whether you've counted it right, okay?
So why wouldn't you do 12?
Oh, okay. So even though the whole circle, you think to yourself like this, you use the whole circle, you're focusing on where's your 1, like where is 1, and 1 is just from 0 to 180. So that's what your whole is, I guess you could say. So, which is a good thing because that means there's less there. Like everybody should do better with quadrants 1 and 2 instead of if we were having to look at all 4 quadrants. You know what I mean? Good question. All right. Go to this slide. So, how far will a point travel if it goes length of the way around the unit circle? Okay, there's a little bit of a code in here. The code would be the fact that they're saying it's going around the unit circle. Now, they're telling you the full rotation is what?
360. 2 pi.
It's 360, but we want to work in terms of 2 pi. So if I only go a quarter of the way, a quarter of 2 pi, now I'm going to do the math first in my head, and then I'll reduce second. Now remember, when you're multiplying fractions, you multiply straight across. So if I'm only going a quarter of the entire unit circle, then that's 2 pi over 4, but that reduces to pi over 2. And that's the answer. All right, y'all try B, C, and D. Is there a reason this is sitting on my desk?
Oh, I was looking for the trash can.
Oh.
I tried to solder it across, but it didn't really work.
So don't reduce them at first, and then so just multiply, set it up, multiply, then reduce. Don't reduce immediately. That way, if you mess up, we can figure out where you messed up. What we're doing is starting to generate the points on the unit circle. These fractions are going to appear over and over and over again, to the point where if someone said a fraction that you've yet to see, you should be like, wait a minute, something's wrong, because I don't remember ever talking about that fraction. It's the same fractions over and over. All right, so if we're finding 1/12, if it only goes 1/12 of the way around, then we would have 2 pi over 12, right? Which is pi over 6. So now what I need you to also do is to start picturing in your head, you got the unit circle. Oh, the marker's dying. You've got the unit circle, so you've got a half of a rotation is pi. Always calibrate it to that. If we're only going pi over 6, then in your head I want you to think of, in quadrants 1 and 2, like 6 equal slices of pizza. So you'd have 3 here and 3 here. Pi over 6 is 1 pi out of these 6 slices. So that would be here. You with me? This is what you're going to start. If you can start picturing this, it makes this whole concept a lot easier. All right, 3/8 of the way. So 3/8 of the entire rotation. So that would be 6 pi over 8, which is what? Y'all get 3 over 4? 3 pi over 4. So now, count it. 3 slices out of 4 in just quadrants 1 to 2. So where would I land? If it's 3 slices, try to visualize this. If it's 3 slices out of 4, I'm landing in quadrant 2. This is going to help tremendously, okay? Basically, the stuff you just did in the mid-chapter 6, you're going to repeat it now, but in radians. Okay? That's what we're going to do. Like, I'm going to tell you, instead of the angle opens up to 160, I'm going to say the angle opens up to 3 pi over 4, and you would have to know where that lands. So that would land like in quadrant 2. Then you would draw the triangle. Then the unit circle means the radius is 1, so then you would go on from there and there. All right, 5 over 6. 5/6 of the way around the whole thing would be 10 pi over 6, which reduces to 5 pi over 3. Now, when the numerator is bigger than the denominator, you still focus on the denominator. So in quadrants 1 and 2, you have 3 nice equal slices of pizza. But this person's an overeater. They ate all 3, and then they ate 2 more. They went back for 2 more. You with me? So that's how you need to visualize it. All right. Come down here. A point may travel completely around the circle and continue, or it can go negative, which remember that means it's clockwise. So remember that negative means clockwise. So this is practicing with angles that, or rotations that go past the full rotation, or rotations that are negative. So this is just trying to give you the visual here. So if you look right here, this one is going all the way around. I'm trying to trace it nicely. All the way. So what's right here? This is 2 pi, right? And then it goes, now imagine if we were just starting here. If it went from here to here, that would be, do you remember? Pi over 2. That would be halfway to pi, right? So pi over 2. So 5 pi over 2 comes about from 2 pi plus pi over 2. And that's how you get 5 pi over 2. Now, if you're thinking to yourself, how did she get that? I got that by looking at the picture. I did not get that by knowing my fractions. Off the top of my head, I don't know that 2 plus a half is 5 halves. I don't know that off the top of my head, like, necessarily. Well, that one actually is not that bad. But let's pretend like it was an ugly fraction. What I do know off the top of my head is that that numerator is bigger than the denominator, right? So I know that it's going beyond quadrant 2. I also know that if you think about it, this is 5 halves as a mixed fraction. Do you remember how to do mixed fractions? Stay with me, Brody. 2 goes into 5 how many times? Twice, with how much left over? 1, 2, and 1 left over. You see it now? So that's another way to look at it, okay? It's going to get easier as we practice. All right, look at this one. This is a negative rotation. Brody, wake up. It's a negative rotation right here. They did not give us the rest of the bullet points, but it's the same concept as, okay, there's must be 4 equal, four equal parts. You got 1, 2, 3, 4, and this is just going one of them. So this is negative pi over 4. All right, look at the next one. We got negative 3 pi over 2. So it's going negative landing there. All right, so let's count it out. Focusing on just the top half or the bottom half. This is negative, so we're going to focus on the bottom half. It's a mirror of quadrants 1 and 2. It's a mirror image. So if I was going just halfway, it would be pi, right? But then I'm going in addition, if I kept going, it'd be 2 pi. So you have to think of it in terms of, we went 1 pi over 2, 2 pi over 2, 3 pi over 2. So you counted 3 sections of just the two sections that make up pi. So this is negative 3 pi over 2. Now, what if I said, what quadrant is negative 3 pi over 2 going to land in? You would picture where it lands, and in this case, it's a quadrantal angle. So you would tell me, because it's negative, you don't say 90. 90 doesn't associate with negative 3 pi over 2. It's negative radian measure, so you would say negative 270. Okay? I don't like that this is all they wanted you to practice, so come over to this space right here and make note, what quadrant is ... We're going to do 2 practice problems. We're going to do 9 pi over 4, and then we're going to do negative 7 pi over 6. 9 pi over 4 is negative 7 pi over 6. All right. The key to answering the question is getting it in a mixed fraction. So 9 over 4. 4 divides into 9 how many times? Nicely. 2 pi. So that's a full rotation, right? All right, and then so you say to yourself, so 4 times 2 is 8, which means I'm not quite to 9 pi over 4, so what's left? 1. Now you have to visualize where does 2 pi and 1/4 pi over 4 land you. Okay, where's 2 pi? 2 pi is what? Full rotation, which means we're right back where we started. So really you just need to focus on pi over 4. So that lands me in quadrant 1. Remember, 1 pi over 4, think of, there's 4 slices of pizza between quadrants 1 and 2, and I'm sticking at the first one, because it's 1 pi over 4. So this would land me in quadrant 1. Another way to get the mixed fraction is to straight up divide the numbers, like 9 divided by 4 equals 2.25. So I can see that's 2 pi and a quarter, pi over 4. So that's another way to get it. All right, negative 7 pi over 6. Okay, so the fact that it's negative means when we go to answer this question, we got to remember that rotation. But first, let's just focus on the numbers. 7 pi over 6. The number on top is higher, which means it has surpassed the quadrants 1 and 2 whole. Like we're calling that the whole, right? That's 1 pi. What would be the 1 pi? Using the denominator. 6 over 6, right? 6 over 6 is 1. And then, so how far past it did it go? 1, because it's 7 over 6. So this, you can say is negative. You can write 6 over 6 if you want. 6 pi over 6. I'm going to go ahead and write negative pi because it's 6 over 6 is 1. And it goes an additional 1 over 6. So 6 over 6 plus 1 over 6 gives me 7 over 6, which lands me where I needed to be. Now I have to actually think of the rotation and think of what quadrant do I land in. Don't forget it's negative. So negative pi means, if you need to calibrate it, think to yourself, this is positive pi. So negative pi lands me right here, right? And then I would go just up a little bit more for 1 over 6. So I'm in quadrant what? 2.
So 1, it's not 6 it's just that 1.
Correct.
Yeah, I got lost because the first one was like the rotation.
Which one? This?
Yeah.
Yeah, this went all the way around. So think of, what we'll do is we'll use the phrase full rotation for when we're talking about going all the way around. And what we'll do is say, wake up, Brady. We'll say whole when we're talking about quadrants 1 and 2. We'll say that's the whole because that's a 1 pi. Yeah. Morning. Yeah. Writing the whole. Yeah, that's great. Yeah. That's all right. I knew where the Starbucks was. I know where they all are to visit every single family member.
You know, when we were in New York
Yeah.
over Christmas, there's one on every corner. I mean, I was in heaven.
Oh yeah, you didn't have to worry about it. Yeah.
Not one bit.
That was a great.
Okay.
I understand it.
Guys, this is going to get more familiar, okay, as we do it. The very first day is usually the toughest because you're just not used to thinking like this, and you also usually hate fractions. And now I'm fixing like this is all we're dealing with is fractions. But I'm hoping to change your perspective of them. Okay, so the purpose of this slide right here is to say, by the way, everything you've just done was dealing with radians. We just weren't calling it that. Okay, so the last two slides, you were working with radian measures. You're used to working with degrees. Now we're going to work with radians. So what is a radian? Okay, it's the same concept as if I said, hey guys, this measures 3 feet. Well, if I said something measures 3 feet, what's another way to identify the exact same length? I could say, oh, this measures 1 yard, right? Or if this measures 12 inches, someone else could say, yeah, that's just 1 foot, Ashley. Same thing with radian and degrees. If I say it measures 180 degrees, what did I just do? You would say, Ashley, that's just pi in radian. You with me? Or if I said it's 360 degrees, you would say, Ashley, that's just 2 pi. You with me? Okay, same thing. Now, why do they call it radian? It's actually kind of cool. So I want you to imagine a dry spaghetti noodle. You with me?
Why a dry spaghetti noodle?
I'm going to tell you. So you got an uncooked spaghetti noodle, right? If it's uncooked, that means I can hold it up and it's like a stick. You with me?
That means if you bite it, it crunches.
Yeah, I know. I eat them. When I'm cooking,
What?
I'll eat like the dry. I just eat 1 or 2. I don't know why.
Are you the kind of person that breaks their spaghetti noodles in half?
No, not necessarily. If my kids want them, I will. But I am the type of person that takes a few out and throws it right up against the stove, and if it sticks, they're done.
You just make a mess.
No, you don't. You don't make a mess because they're going to stick, and then you just wipe it off. See? All right, so picture this. Dry spaghetti noodle. Not dry. Uncooked. Dry. Uncooked spaghetti noodle. So it's like a stick, right? Okay, that is the unit. That's the 1. That's the radius. And to make the circle, it goes all the way around. With me? Okay, now, cook the noodle. Can't really demonstrate this one.
Cook noodle makes.
Cook the noodle, so now when
Cook
I go
noodle
to pick
makes
up a
circle.
noodle, it's not going to
Go
stand up like a
woo.
stick. It's going to be wobbly, right? Take
It's
a
like-
cooked noodle.
It's like a
It's
string.
like your string, correct. Take a cooked noodle. You with me? Did the length of the noodle change
No.
when I cooked it? No. You with me? Length didn't change. Take the cooked noodle. I want you to lay it from 0 along the edge of the circle. Because now it's, what's the word, amiable? Like you can turn it.
Turnable?
Whatever.
Amiable? Let's get back to that. I don't know what's amiable.
What does amiable mean? I swear it's a SAT word.
Spaghetti noodles are not whatever that word was.
There is a word, there's an SAT word for
Movable?
like it will bend.
Valuable.
Malleable.
I'm so smart, guys.
Did you say it? Malleable. I said amiable.
Hashtag chemistry.
Amiable means friendly.
Chemistry.
It's the same thing. It's a friendly noodle. Okay, if you have a noodle that's cooked, it's malleable, meaning you can bend it however you need to. Imagine a cooked spaghetti noodle and you lay it around the edge of the unit circle. Where it lands is considered 1 radian. So this is actually, I find it really cool. Like where they land the spaghetti noodle is considered 1 radian. Okay? All right. Now, there's an actual number behind it. It's about 57.3. There's a little bit more behind that.
Why did we start with an uncooked one?
Well,
we
because
just started with the cooked one.
I needed you to know that it's the same.
I thought you just want spaghetti.
No. Okay, so here's the connection. Look right here. What? No, I'm not on something.
He didn't say that.
The
I said you're
noodle.
hungry.
The noodle always. The noodle that is not cooked, right? It represented the radius. You hear it now? It represented the radius. Stay with me. The radius of a circle goes all the way around and it never changes in length. Now cook the noodle and laid it around the edge of the circle, that's the radian. So they took the radius, they cooked it, and then they laid it around the edge of the circle, and now it's called a radian.
Let them cook.
Okay? What'd you say?
Let them cook.
Don't leave here. Say Miss Holcombe was cooking it. All right.
I am
So
good.
That's a good thing. That's
Hey,
not
that's
bad.
top. That's
Does that not mean like something negative? Like
No, it's good.
oh, okay. Well, she was.
That doesn't
cooking
mean
them
you're
out.
cooking crack cocaine.
Okay, that's what I was worried about.
No, you're cooking.
All right.
Put you in the
Theta in this
Oh,
representation is 1 radian. So now, if you think about 1 radian as about 57 degrees, if I have 2 of them, then I've clearly busted 90 degrees, right? So I'm going to land in quadrant 2. Sorry.
Look, you were cooking, now you're not cooking.
Oh, not cooking.
Now
Sorry.
you're busted.
I said busted. It busts because it's 2.
Moving on.
You know, sometimes I think I understand y'all's language, and then y'all.
Let's
Y'all remind me I'm 40, so thanks.
allow the study.
Okay, go back.
Okay, all right, I'm going back to cooking. All right, we got 2 noodles cooked here. Okay, there you go. Here we've got 3 noodles cooked, still in quadrant 2. And the way you get this is you think about in terms of 57, like 57, 57, 57. And then here we've got 6 radians cooked. So you think about in terms of 6 57-degree angles, and that lands us in quadrant 4. That little gap, so that's where radian drives me nuts because it doesn't close nice and neat right on 360. And it drives me nuts. Now, the good news is the whole 57 thing does not come up a lot. Instead, we just say 1 radian, 2 radian, 3 radian, pi over 4 radian, pi over 6 radian. So that's the good news, okay?
Is
Now-
there like a specific reason that it's 57.3? Or is it just like the first
Honestly,
number
I don't remember the math behind where the 57 came from. I think it's because of the 1 unit circle, like 1. It's where 1 lands on the edge of the
That
circle.
looks like fun.
All right, so
I
go
thought
to
the
this.
red dot on the bottom of the corner meant stop.
Do you remember what I was saying?
Oh. Oh yeah.
All right.
We're busted.
Everything, now listen, everything that you've already done from the last section, you're fixing to do, but now with radians. This slide right here is to show you those quadrantal angle values, okay? These are your anchor points. So this first one right here, you're used to saying the angle would be 90. Now you're going to say the angle is pi over 2 radians. Okay, so let's label. Here, don't worry about the 1.57 radians. Don't worry about that. That's in decimal form. We're not doing that right now.
That looks wrong.
Right now.
Well, I mean, eventually it'll say give it to me as a decimal. You just type it in the calculator. Yeah. All right. So if this was given to me as a picture, I would think to myself, start here. I know that if I land here, I'm at pi. So if I'm backtracking and it's exactly half of it, then that's pi over 2. I don't like where I wrote that. Let me. Pi over 2. Right? And this is the 90-degree angle. Okay? Come to this one right here. I don't know if you want to do a highlighter on these rotations or not. So we start here. We're opening up and we're landing here on pi. What is the degree measure of pi? 180. What's the degree measure of pi over 2 when we just did? 90, because half of 180 is 90. All right, let's come down here. We got, so we're going, starting here, right? We're going to open up, so we're definitely going past pi. but we're not going all the way, correct? So how many sections do you see? 3. Now we have to count in terms of, so if you look at this, always come back to pi over 2. Okay? So this is 1 pi over 2. 2 pi over 2, which is 1 pi. And this would be 3 pi over 2. Now if you need to write it, then you can, right? This is pi over 2. This was 2 pi over 2, which reduces to pi. So in terms of degrees, it was what we're used to calling 270 degrees. We're going to now start calling it 3 pi over 2. Alright, a full rotation is 2 pi. So it starts here, it rolls all the way around, and it lands here. This is, 2 pi, or 360 degrees. How do you remember that the full rotation is 2 pi? Just remember 2 pi's are better than 1. Right? How's that? Allie's looking at me. 2 pi's are always better than 1.
I'm just gonna remember 1/2 2 pi squared somehow.
So do you call it pizza a pie?
No. What?
You call pizza a pie?
No.
Why do you do that? Why are they stupid?
Yeah, I think in there a restaurant called Your Pie.
Yeah, but it closed down
And
now.
it's pizza.
Yeah.
It's just pizza.
Okay,
Yeah.
as
I
we
like that.
answer these questions,
We should make
these
a
are your like anchor points, okay? You're going to start to hear me say, you might want to sketch like one unit circle, draw your quadrants, and then label, and it might help, okay? All right, let's get to the actual practice. That wasn't practice. That was kind of getting your bearings. Converting between radians and degrees. Okay, so go back to when I said, if I call this 3 feet, you would call it a yard. If I call it 12 inches, you would say it's a foot. Okay, radians and degrees, you can convert back and forth between the two of them. The conversion is in the box at the top of your paper on this slide, sorry. Notice it says that pi radians over 180 is equivalent to 180 over pi radians, and then it says, and they all equal 1. It looks confusing, but it's the same thing as if I said 12 inches is the same thing as 1 foot. Remember this stuff? Or if I said 3 feet is actually 1 yard. They're saying pi is 180. They're one and the same, which is why if you were to divide them, you get 1. Okay. Now, how are you going to remember this? Because you do have to memorize this. All right, y'all know me. Here I go. Ready?
Uh-oh.
Here we go.
Is this something
Okay.
about Costco?
Oh, no, it's not about Costco.
Transport and cargo.
No. The top is the form you want. The top of the fraction is the form you're trying to get to. So you focus on, it's kind of like if you're getting in the car and you're driving somewhere. Nobody cares about where you are right now. The goal is to get to your destination, right? So you focus on the destination. What's the goal? So if I'm trying to convert from degree to radian measure, then radians would be in the top. And now you've got to know pi means radians every time. Y'all with me?
Yes.
Pi means radians. If it's a degree measure, then it's degrees. You with me? Like if it's got a degree symbol, might want to write that down. If it has a degree symbol, it's in degrees. If it has no degree symbol and there's a pi, it's radians. Pi goes with radians. Degree symbol means degrees. Okay. So if I'm trying to go to radian, pi goes on top. 180 on bottom. If I'm trying to go to degree, 180 goes on top, pi on bottom. Now let's make notes. This is not on the formula sheet. You are going to have to know it. Now, I'm not asking you to sit down and memorize that fraction. I'm asking you to memorize that pi and 180 are the exact same landing spot on the unit circle, which means they have the same value. And to answer the question, you're going to multiply by the one you're trying to get it into that form. All right, so let's practice. Convert each of the following to radians. Two things. First of all, it's flat out telling me to go to radians. Second thing, it's in degree, so my answer needs to be in pi. Okay? So that's two ways to know what to do here. So I'm going to take this and I'm going to multiply by what it tells me to go to. It's saying get it in pi form. So it's going to be times pi over 180. Now, when you go to your calculator, let me pull mine up. Here's where you need your calculator. Here's where something. Okay, here's the problem. Don't enter pi.
120. It's just 3.14.
Don't enter pi. Why? There is a pi button, but do you remember?
You put 3.14.
No. Do you remember what we know about pi?
No.
It never ends. Does it have a pattern?
No.
There's no pattern. Do you remember the math word to describe a decimal that never ends with no pattern?
Irrational.
It's irrational, which means it cannot be written as a fraction. All of our answers need to be fractions. So while we will write pi on our paper and in our answer, you will not compute it or you will be stuck.
So it's literally just going to be.
You're literally doing just the numbers. So in this case, now you need to know that this is understood to be over 1, right?
Oh, so it's just 1.
So it's 120 pi over 180.
Where'd you get 1 from?
Hold on. 120 pi over 180, and you would go to your calculator and you would type 120 divided by 180 and math frac it. Math frac. So it's 2 pi over 3. So you might want to make a note to yourself right here.
Don't touch
Don't
the pi.
type pi in the calculator.
Don't touch the
Pi is there to let you know it's radians. Pi does not actually get typed in.
That's what I meant. I should replace pi with 1.
Now, even though you have this ugly decimal here, right?
Who cares? Put it over 180.
It is ugly. So we're going to multiply by, is it?
No.
It did it. I don't,
Pen? Or are you on?
I should be on the pen.
You're not on the pen because.
No, you're right. I was on the erasing. Okay. I'm gonna apologize.
Wah, wah.
All right, so we're gonna multiply this by pi over 180 because we're trying to get it into radians. And so just negative 297.255 over 180. It is a very ugly fraction. So we got negative 279.
What in the world?
125 divide 180.
What?
Math frac.
You did something wrong. Why is it so big?
So So,
Who cares?
no, I didn't get that. What did I do? Oh.
Nine.
There we go. Negative 1,189 over 720. Okay.
That's a bit ridiculous.
All right, hold on. So negative 1,189 pi over 720, right? Now, coming back to this, 2 pi over 3. That should look familiar. We've talked about that. Anybody know off the top of your head where that lands?
About there.
The bottom,
270.
270. And another way to think of it is, no, 2 pi over 3. No, 2. You're thinking of 3 pi over 2.
It's in quadrant.
It's in quadrant 2. Has it hit 1?
No.
So look at the denominator. Ask yourself 3 over 3. Has it hit 3 over 3 and passed it?
No.
It is not, so backtrack. So that's how you know it's in quadrant 2, right? Okay. Can you tell me where this one is?
No.
Nope. So if I
Quadrant
wanted
3.
you to actually tell me, go to your calculator and actually type now the whole thing in, and let's get the actual radian measure in decimal form. So include the pi. So I want you to go to your calculator and type negative, or you could just take your answer right here and say
Right.
times pi. Pi is the
Above the
above the caret.
Math, frac. Oh, it's negative 5.187991202.
So that's how many radians in decimal form. So this is fraction form. I can find this on the unit circle. I know where 2 pi over 3 is. This is a random, like, ugly number. I can't find that, but I could type it in my calculator, and it's about negative 5.19. Now, if you've typed pi in the calculator, watch how I do this. Then over here, you would say radians. Now, this is radians as well, but it's in pi form. If you've already evaluated the pi, then you would say after it that this is radians so that you don't confuse it with degrees. It's not degrees. All right, so that's the answer, but then we're looking at the decimal form to get an idea of where it lands. All right, now let's go in reverse. Convert each of the following 2 degrees. If I'm going 2 degrees, what needs to be in the top of my fraction?
180.
180.
Because you want the top.
So we've got 3 pi over 4 times 180 over pi. What do you notice happens here?
The pi's cancel out.
The pi's cancel, right? So in your calculator, this is when I like to use the fraction shortcut. Alpha y equals, so I can see 3 over 4 times, I can do 180 in a fraction, or I could just say times 180. And I get 135
Dude.
degrees, right?
How do we do number B?
What?
Do it the same way, but you should notice there's no pi, which means the pi's don't cancel because in this case it doesn't have one. So we do have to type the whole thing in. So this is in radians. This means the pi got multiplied in here. You want to make the note. So we're going to take 8.5. Actually, let me make the note right there. We're going to write careful. There is no pi. Because there's no pi, this means that we have to use pi when we multiply. I'm not trying to rhyme. We have to use pi when we multiply in order to answer the question. So you go to your calculator and you're going to type 8.5 times alpha y equals, I'm going to do 180 over pi. And you get that it's 487 degrees. So while this is very simple, where you can get tripped up is if you're not paying attention to is pi in there yet or not. So 487 degrees.
I say stop here.
Negative. 2 more, and then we'll stop. Look at the next slide. The next slide is saying, he's putting it all together for you. Now, it's in 2 different pictures, okay? So that it doesn't get crowded. But if you take these pictures and you superimpose them on top of each other, you have the unit circle, which is what we're getting to. Okay, so if you take note, this picture is broken into quarters, and then this picture is broken into sixths, which reduces to give you those thirds and halves, okay? So it's quarters or 1/6 is what they're counting by. The takeaway from this slide is if no unit is given for a rotation, meaning if they don't tell you the angle is degrees or radians, then it's understood to be in radians. Now this doesn't happen a lot. 9 times out of 10 you know which one you're in, but it will come up just a few times. So if you don't know what the angle is actually measured in, because it doesn't say it, doesn't have a degree symbol, doesn't have pi, doesn't say radians, then you assume radians, okay? Which means you assume the pi got multiplied in there. And that's why you can't see it. All right, so start looking at this, start getting familiar with these numbers and fractions, because this is where we are for the whole semester, okay?
Are we going to have a test coming up?
Yes.
Quiz over just
You're going
the
to
unit
fill in the unit circle from memory. And while it sounds very stressful, Luke, can you please chime in and say that it was not that bad?
It's okay.
circle. That makes me feel a lot better. Thank you.
Well, you see what he's doing right now?
Yeah, you see what I'm doing right now?
Mm-hmm. All right. Look up here. Do you remember in the last section when you were finding the coterminal angles or the complement and the supplement? Okay, same thing, but now we're saying instead of add or subtract 360, there you go. Instead of add or subtract 360, now you're adding or subtracting 2 pi. So let's make a note. Instead of plus or minus 360, draw an arrow, we are now going to do plus or minus what?
2 pi.
2 pi. It says find a positive and a negative angle that are I'm going to finish writing this, coterminal with 2 pi over 3. And it does say, by the way, many answers are possible, but I'm going to go with just the one rotation away. So we've got, I can't stand fractions written out linearly. We've got 2 pi over 3. We've got to find a positive and a negative. How would I find a positive? By the way, that's already positive, right? So to get another positive,
Plus
I would...
2 pi.
Huh?
Plus 2.
Plus 2 pi. Now, when you go to your calculator, don't type pi in or it's going to produce your answer in radian decimal form that we can't work with. You're going to type just the numbers in. So make a note to yourself. Calc, don't type pi. Don't type it. So you would type 2/3 plus 2. Get it in math frac form. Did you get this? So that would land in the exact same spot as 2 pi over 3. But it would have a full rotation in between it. What about a negative coterminal angle?
90.
Minus 2 pi. So you can hit in your calculator second enter, and it will repeat what you just typed, and you can go in and just change that to a minus. So alpha y equals 2 over 3 minus 2. So negative 4 pi over 3. All right. The next one, same thing you've already done, but you did it in degrees. Now we're going to do it in radians. Let's take a few notes because a couple people got these wrong on the exam, and I really don't want you to get them wrong. Remember, the complement means they add to what? Add to 90, which means now they add to pi over 2. You've got to memorize that 90 is pi over 2. The supplement was that they add to 180. 180 lands at what? Pi. So now it's that they add to pi. If you need a picture of that to remind yourself, remember this is 90, but we are now going to call it pi over 2. Remember this is 180, but now we're going to call it pi. Okay? Commit that to memory. It helps. Okay, it says find the complement and the supplement of pi over 6. It's as simple as knowing what they have to add to and subtracting off the one angle it gave you to get the one you need. So if I'm finding the complement, right, C-O-N-P, remember a C can be turned into a 9, so that's how you remember that's the 90. So I'm going to take pi over 2 and subtract pi over 6. Do you enter pi in the calculator? No, don't you dare, because then the calculator is going to compute it. We need it to stay as fractions. So you're going to enter 1/2 minus 1/6 in the calculator.
1/3.
Mm-hmm. So you would write pi over 3. Please don't write 1 pi because my math lab will mark it wrong. All right, supplement means they add to what? Pi. Watch how you can do this in your head. You don't need a calculator. Ready?
Yep.
You know, supplement can be turned into an 8. You should think 180. That's pi. So I'm going to take what I know it adds up to, and I'm going to subtract the one they gave me. Now here's how you do it in your head. This pi represents one entity, right? This one that I'm subtracting off is in terms of how many pieces? 6. So what is 1 using like 6 pieces? It'd be 6 over 6. Does that make sense? So I'm going to fill this in, 6 over 6. Now subtract straight across, what do you get? 5 pi over 6. Now if you don't want to do it in your head, you don't have to. I just wanted you to see how I did that. I built the 1, I rewrote it in terms of 6 pieces.